Anyway, getting back to the normal program, I'd like to welcome our next speaker, Martin Brown from Renesys, who's going to be talking about the follow-up to the Taiwan earthquake analysis.
How does this?
Good question.
Sorry, one quick announcement. Could you ask Michael Sinatra, whose lightning talk was accepted, to please contact Valerie or me and say that?
Do you need to do that now? Okay. Okay, if Michael Sinatra, whose lightning talk was accepted, could contact Todd or Valerie to get the slides sorted out, that would be appreciated.
So how does this thing go full screen? Thank you. So greetings, good afternoon. My name is Martin Brown. I'm a data engineer with Renesys, and I'm going to talk about the aftershocks of the Taiwan earthquakes. We're going to take a look at the shape of the after effects, the immediate after effects of the earthquake first, which is a reprise of a talk we've given at Apricot last year. And then I'm going to talk about the shift in transit patterns, essentially the fallout immediately after the earthquakes and for most of 2007. So in order to do this, I'm going to introduce some concepts of how to get some kind of sense from BGP data how big a market segment is and how big a geography is. So, and I'll also introduce a concept sometimes if you're looking at a particular relationship between two providers, sometimes just looking at the number of prefixes carried by that provider isn't quite adequate. So I'll introduce these topics and then I'll take some questions at the end. So we'll get started. The submarine cables that were cut on December 26th and 27th of 2006, there were a total of 9 cables. 2 of them were not cut, Asia Netcom, ZAC, Guam, Philippines, and they were reported repaired as of February 14th of 2007. So the interesting things just to take away for looking at in the slides that follow is that we have an event that occurs on the 26th and the 27th of December, and then we have a repair event, the completion, that occurs on February 14th. So who is Renesys? What do we do? Renesys has 200, we're basically like route views, but we do more with the data. So we have 250 full table peering sessions with over 170 ASs across the internet. Sometimes we pair with an AS, we have multiple peering sessions to get some geographic redundancy. In all, we cover we're one hop away from or directly adjacent to 65% of transit edges. So that gives us a good deal of visibility into global transit and global transit patterns. So in this talk, we're really only going to focus on the prefixes that geolocate to the set of 22 countries that were affected by this outage. So we're really trying to zoom in on what happened in the immediate aftermath of the earthquake in terms of transit, and then what happened in the remainder of 2007. So this stuff is old hat for all of us. A network outage is when a large number of routers worldwide remove or withdraw a prefix. An unreachable is when there is no covering prefix for that network. And instability is something that we're particularly interested in. Instability is when we see a lot of activity, both BGP advertisements and withdrawals. This can be route oscillation, this can be any number of things, but typically indicates some kind of, sometimes indicates a physical problem. Sometimes it's just router misconfig. So what I'm going to look at, I'm going to speed through fairly quickly the shape of the immediate aftermath of the earthquake, and then we'll actually zoom in on the transit changes over time as a direct result of the earthquake, and then for the remainder of 2007. So the first thing to note in the following 4 graphs is that we see a ramping up of outages and spikes in instabilities. In the next slides, take a look at we'll point out the big spike. The big spike on December 27th. We see a grouping of earthquakes on the 26th, and then we see an earthquake on the 27th, which really seems to have a big effect. The recovery pattern We're seeing a typically noisy recovery pattern, and we want to emphasize that that's probably because this is a large number of distinct physical events that mean a number of different events that are occurring logically. So let's zoom in on the outages immediately after. This is in the immediate aftermath of the quake. So on the right-hand scale, we have the seismic magnitude, the Richter scale for the magnitude of the earthquakes. The first earthquake occurring on the 26th, magnitude of about 7, and there was a grouping of, 4 or 5 there? 4 or 5 earthquakes on the 26th. So now we see a slow, note that that curve comes up fairly slowly. It's not a peak. But that earthquake very early on the 27th, UTC, seems to have made quite a big hit. Now I was thinking about it. Do you all know the game Jenga, where you've got all of these little sticks that you pull, and you keep pulling out sticks, and eventually, well, the whole thing falls over. And I'm kind of likening that mentally to that's what's happening here. That's what we're seeing. You're going to see the same pattern when we look. This is outages. So what this graph is telling you is that of the set of prefixes that geolocate to these 22 Asian countries, what we're seeing is that about almost 4,000 prefixes suffered an outage that we can pretty much directly correlate with that earthquake that occurred on the 27th. So now we can actually break them down and look at which countries were most affected. And China and Indonesia and India were hit pretty hard by this. So I'm not going to spend a lot of time on this, and going to move on. We'll take a look at instabilities. Instabilities, we see essentially the same basic shape of the pattern, but instability, we see a little bit more noisiness. And then we can also break that down by country. So we can take that and take a look at what were the most heavily hit countries. And in fact, China, India, and Indonesia come up pretty strongly here, show up pretty strongly here. So now, one of the things we also want to do is we know that outages and instabilities are a fact of running networks, particularly when we're talking about really large markets. So we wanted to get a sense for how severely did the earthquakes affect these markets. So what we did was to try to factor out a baseline state of outages and instabilities in each country, and then compare that median to the peak, and to see who was hit the worst. China and Hong Kong hit the worst. This is a graphing of the ratio of median instability. So in the 2 weeks prior to the earthquakes, we're comparing the median instability to the maximum instability. So what this tells us is that there's about 70 times more outages at peak in Hong Kong as a direct result of the earthquake. 55 times more in Taiwan. Hong Kong, Taiwan, India, pretty badly hit in terms of network outages. In terms of instability, well, see, now China didn't do so badly in terms of outages, but China was severely hit in terms of instability. China shows 1,300 times more instability in the 10 days after, in the 10 days of the earthquake than the previous 2 weeks. So China was pretty badly hit, Hong Kong as well. So now this is actually that's just a lead-in to kind of say this is the shape of the earthquake event, and now we want to take a look at what did it look like after the event. How did transit patterns change? Who went to new providers? So in order to do that, we need to kind of take a look at transit relationships. How can we take a look at these transit relationships, identify them into market segments and geographies, and then do some sort of using objective criteria, come to some kind of sense of how big a provider is in a market. So we do this by scoring and then ranking. So the scoring mechanism is actually, this slide identifies the scoring mechanism. I'm going to go through it. I'm going to start from prefixes. The slide starts from ASs. So we're going to geolocate all prefixes. we use a couple of different sources of geolocation data, and we coalesce them. And so now we have a location for a prefix. We assign a score to that prefix. So, and a larger network, a shorter prefix, is going to get a larger score. We also discount for CIDR, so any pre-CIDR assignments, we discount those because we assume that they're going to be less well utilized than a CIDR assignment or a more recent assignment. So we account for date of assignment and then also the prefix length. We assign the score. Now, we also know the transit pattern that is announced, that shows up in the routing tables. So what we do is we aggregate, we actually ignore any more specifics you may be announcing that share the same transit pattern. So for example, if you have a /20 and you have a /24 and you're announcing them and we see the same transit pattern, we're actually going to ignore the /24 and we're going to use the /20. So we'll assign a score based on the /20. So at this point we have a prefix. We've done the prefix calculations. We've got a prefix, we've geolocated it, we have a score for it, and we know the transit pattern. Now we're going to take a look at all AS to AS relationships. So we look at every single AS pair adjacency that shows up on the internet. We're going to assign a relationship to that edge. It's a transit edge. It's a peering edge. There are some more unusual relationships, such as transit swap, AS clustering. AS clustering is where one organization uses more than one AS. But we're basically, for purposes of this discussion, we're really interested in those transit edges. So now we've got transit edges that are tagged. And now we can take a look. We can combine. We know which edges are transit edges. And we know we have a score for a prefix and which edges it shows up on. So this is computationally intensive, but it's quite simple to take a look at the transit pattern and say, well, this is a retail, this fits into the retail market, this fits into a wholesale market, and this fits into a backbone market, just by looking at where a prefix shows up, where the AS relationship shows up on the prefix's transit pattern. That gives us a way to calculate a score, sum a score to a geolocated region, or to a market. So that's how we do rankings. Rankings, the score itself is not intrinsically valuable. What is valuable is looking at the relationship between those scores because we can get a sense for the relative size of a provider or the relative size of a market, the relative size of a provider in a geolocated market in a particular market segment. So the rankings give us that. They do not give us actual traffic volumes. We can't see that from BGP data. We don't see profitability, we don't see network quality, we do not see any customer satisfaction, and in particular, we don't see anything, we can't divine anything about transit location, not intrinsically. However, we can see, here are some things we can see from rankings. We can get the sense for how big is a provider in that market. So we can see, by looking at this, we can see who's a big retail provider in Hong Kong, who's a big wholesale provider in Malaysia, in China. We can also get a sense for whether a provider has a physical presence in a region. If you have a retail score, if you're showing up on that first edge, immediately adjacent to the origin, you're probably physically in that market. The case that we point out here, Sprint carries an awful lot. It's the biggest backbone provider to China. But it's one of the lowest in retail market. What can we conclude from that? Well, we can probably conclude that they don't have a great physical presence. They're probably even, we're guessing, they're probably even transiting the prefixes from someplace else. So the most important thing that we can learn from this is that we can learn whether a particular provider is gaining or losing market share. These are the countries that are were most affected in the earthquakes, the ones that are colored in, and we're going to take a look at some. We're going to take a look now that we know like how we do the scoring. I'm going to take a look at where we break down in terms of country and then where we break down in terms of provider. So we can then take a look at what, in a particular market, what are the per country growth rates? We can look at the total market growth rate. We can also look at how the different markets compare in size, how the different countries compare in size, and in particular, the point of the talk, who has gained and who has lost transit, and why. So here we have, so now the score, remember that the absolute score is not intrinsically valuable, but the relationship is. So the relationship of absolute score, the percentage. So in this case, take a look at Taiwan. Taiwan is 22% as big in terms of this market size calculation. Taiwan is 22% the size of China. That's what this is telling us. So now the year-to-year rank change shows how much, whether it has gone up in terms of relative size or down. And the year-on-year growth is compared, how much larger is that market by this calculation? How much larger is this market today than it was a year ago? So the biggest growing markets are India and Vietnam. Vietnam more than doubled in size. So now we're going to take a look at 4 of the 22 countries that were most keenly affected by the Taiwan earthquakes. We're going to take a look at the breakdown of who's serving them. So this shows, in red, you'll see the providers that we're going to zoom in on in the next graphs to actually show how many prefixes were carried on edges that are interesting. This is actually the key point here. By doing this complicated scoring mechanism, we can actually identify which edges are interesting to look at. And that's where we can then zoom in and take a look at how many prefixes were carried on that edge over time, and we can see growth. Sometimes that metric isn't quite sufficient, but most times it is, so we'll zoom in on a couple of these in the next slides. In particular, I want to point out the big jumps out of nowhere, Cable and Wireless, Tiscali. Telecom Italia actually jumped 15 places as well, and there's an interesting story there. So first, this is clearly correlated with the earthquakes. This is fairly unambiguous. The earthquakes occurred right around 26th of December, and we see that the transit pattern, suddenly China Telecom is visible through Chunghua. And then right around the time of the repairs, bang, they're visible back through Sprint. So this is a pretty clear correlation of the immediate after effects and how China Telecom dealt with the situation. They got transit from Chunghua. I believe Chunghua was having some congestion issues as a result of being a transit provider to a lot of other providers in the region during that time. So AT&T, you can see that right away they actually, hang on just a second, I need to check my notes. AT&T lost Hanaro pretty much right away, and then right around the time of the repairs, curiously, the green line, VSNL, curiously, right around the time of the repairs were complete, VSNL drops off. So AT&T lost these 2 customers, but did fairly well with Bharti, and lost a little bit with Asia Netcom. So the interesting thing to note here is just the physical correlation with the event, right? Hanaro and VSNL. Those are pretty clear and unambiguously related to the transit shakeup after the earthquakes. So now Singtel did very well, grew quite a bit over the year 2007. We see, of course, that they pick up China Netcom toward the end of the year. But what is quite interesting is actually to see Vietnam Post and Telecom almost immediately after, not quite, but almost immediately after the cable repairs were complete at mid-February, we see Vietnam Telecom suddenly choosing Singtel. So Singtel won pretty well there. PCCW jumped 10 points. They picked up a cable provider, mobile operator out of Singapore, StarHub. And note that they picked them up also fairly close to the cable repair point. So cable repair, and suddenly, look at that. PCCW picks up StarHub. So now the next one is actually a bit problematic. We know, actually, after looking at the rankings, that Telecom Italia, remember, they jumped 15 places in the rankings. So they clearly got something. Now, we took a little bit of time to kind of narrow down and take a look at see who they got. Well, they got Telecom Italia picked up Singtel. Okay, but why do we not see such a sharp increase in the number of prefixes carried on this link over time, on this edge? Well, that's where this, the simple metric of prefixes over time often tells the whole story, but sometimes it doesn't tell the whole story. So we need to actually talk about a different way to measure from the set of peers that can see the internet, how many people are choosing one path over another. So we have a metric called prefix peer time. I'm going to describe it this way. Imagine that I'm a customer and I have provider A and provider B. I advertise my prefixes to both. Okay. Some places on the internet will select the A edge, some will select the B edge. What the PPT measure allows us to do is to quantify how much of the internet is actually using the A link and how much is using the B link. So this is not from traffic information, this is strictly from a diverse set of peers. So what we can do, assume 100 peers. We've got 100 peers, and for one day, we see that 99 peers are choosing to send their traffic inbound on link A, edge A. One is selecting edge B. Well, we can get a pretty clear correlation there and guess that edge A is pretty important and has picked up some traffic. So that's why we can then redraw this graph. Now note the difference between, this is prefixes over time. So there is some fluctuation. You see very clearly the quake-induced stuff early on, and then it kind of disappears here. So the peer prefix time metric gives us a good sense for picking up transit relative to how many different peers see that inbound path selected. What this tells us is that in the aftermath of the quakes, the world prefers to use Telecom Italia to reach Singtel. Now we're going to go back to, in most cases, prefixes over time actually tells us quite a bit. So we're going to go back to talking about prefixes over time. Not directly related to the aftermath of the earthquake, Cable and Wireless has picked up Bharti and Telecom Malaysia, jumped 627 slots to position number 17, and we see a nice little leak here in early to mid-November. We see a nice little leak there on that edge. Tiscali did very well in the entire region over this time. Tiscali gains from Asia Netcom, picks up quite a few prefixes to the tune of 6,000 or 7,000, picks up providers in Hong Kong. This again is not something that we can correlate directly with the earthquakes, but occurred over the remainder of 2007. And then Tiscali also cleans up pretty well in the Philippines. So finally, well, China grew at 37%. What happened to the Chinese providers? Well, in fact, the Chinese providers grew, but they didn't grow relative to the other providers. So they lost places, even though the entire marketplace is expanding. So, in conclusion, we're still living with a fragile internet, particularly in Asia and the Middle East. For those of you who saw Aline Popescu, my colleagues, talk yesterday about the immediate aftermath of the cable cuts in the Mediterranean recently. So local events can still have a broad effect, and we need more capacity both east and west. I'll take any questions.
Hello, Ken Emery from CNET Networks. Were you able to detect any partitioning where, like from Japan, you could get to China but not from the United States?
That's a good question. I think we probably could see that. I don't have any data on that at the moment, but we have seen that in the past, a kind of partitioning. It's quite true. I mean, when you have a diverse set of peers, you can see this kind of thing where parts of the net can't see each other. So that's a very good question.
Alin Popescu from Renesys. I wanted to add one thing regarding Telecom Italia and Singtel. Actually, prior to the earthquake, Telecom Italia and Singtel were peering, and we were seeing across that edge a significant number of prefixes. After the earthquake, that relationship changed to transit, and the absolute number of prefixes actually dropped to a certain extent, but it ended up being picked by pretty much the whole internet. That's why we see a significant increase in like the peer prefix time metric, while actually the prefix over time even drops a little bit. So,
thank you.
Paul Ferguson. Could you draw even like a 50,000-foot overview comparison of the severity of the outages from a AS and prefix perspective, comparatively speaking, between the this Asia Pac outage and the more recent one in the Middle East, on this, just the severity and the amount of outages, and actually disconnectivity as opposed to instability? And there's a reason why I asked that. I'll come back if you could.
Yep. I'm not sure I can do that on the fly. That's something that certainly we can do with the data that we have at hand. And it sounds like I would bet that Todd is about to address that a little bit more directly than I could.
I can do that on the fly. The press hubbub about the recent stuff was a sort of 2 orders of magnitude more than the press hubbub about Taiwan, but the Taiwan instabilities and outages were 2 orders of magnitude more severe than the Alexandria cuts.
Because one of the things we saw, actually comparatively speaking, that from the security perspective was, though, on the Taiwan outages, we saw a significant dip in spam and botnet activity immediately following that. Which we did not see with this most recent one. And I don't know exactly why that might be. It might be due to various reasons that may have no actual real bearing on either.
You're saying the Middle East is not as good at spamming? Is that what you're saying? That's kind of insulting, I think. I'm just saying.
Anyway.
Thank you, Paul. Any other questions?
Okay, thank you very much, Martin.
Thank you. Thanks very much.